Hey everyone, good morning. I am Priyanshu Agrawal and welcome back to my YouTube channel. Now we are going to solve today's Leetcode daily challenge, which is recover a tree from pre-order traversal. Okay, so let's see what is this question and how we can solve it. So in this question, we are given with we run a pre-order depth first search DFS on the root of a binary tree. Okay, so if you don't know about what is pre-order, so let me tell you. So let's say if you have some tree 1, 2, 3, then the pre-order traversal is the root and then its left node and then its right node. So the pre-order traversal of this tree will become 1, 2 and 3. Okay, so the pre-order traversal is root, left and right. Okay, so let's see the question further. And at each node in this traversal we output d dashes where d is the depth of this node. Then we output the value of this node, and if the depth of a node is d, the depth of its immediate child is d plus 1. Obviously, let's say the depth of 1 is 0, then the depth of 2 is 1. So the depth of its child is d plus 1, the depth of its parent plus 1, and the depth of the root node is 0. Okay, and if a node has only one child, the child is guaranteed to be the left child. So this is an important point. And you have been given the output traversal of this traversal. Recover the tree and return its root. Okay, so let's see from the test case that you have been given with this traversal with the value, and dashes represents the depth of that node, and from this traversal you will need to create this tree. Okay, so from this traversal, if you need to create this tree, so somehow we will need to get out the information from this traversal, like what is the depth of a particular value. Okay, so let's see. So let's see from this traversal, the value is 1 and the depth is 0, right? Okay, and after that there are 1 dashes. It means depth is 1, and after 1 dash, what is value? Value is 2, and after that the dashes are 2. Okay, so depth is 2 and the value is 3. Okay, after that also there are 2 dashes. It means depth is 2 and value is 4. Okay, after that there is only 1 dash. It means depth is 1 and value is 5. Okay, and after that there are 2 dashes. It means depth is 2 and value is 6, and after that there are 6 dashes. It means depth is 2 and value is 7. Okay, so somehow we can get to know this information from this traversal, and with the help of this information we need to create a binary tree. Okay, so let's see how we will create the tree. Okay, so as we have been given in the question that the depth of the root node is always 0. Okay, so its depth is 0, so it means the value of the root node is going to be 1. Okay, so let's come on to the next value. Depth is 1, its depth is 0. Okay, so the depth of the child node will be the depth of parent plus 1. Okay, so yeah, this can be its child node, and as it don't have any child nodes till now, so the coming node will be its left node, as we have been given this here. If there are no child nodes in the parent, then the coming node will be its child node. Okay, let's go to the next value. Depth is 2 and value is 3. Till now depth is 1. Okay, can this be the child of this node? Yes. Okay, so let's create its child. Now let's come on to the next value. Here depth is 2. Okay, now can 4 be the child of 3? The depth of 4 is 2, the depth of 3 is also 2. No, 4 can't be the child of 3. Okay, let's look at the previous node. Can this be the child of 2? Yes, its depth is 2 and the depth of 2 is 1. Yes, but it already have its left child. So 4 is going to be its right child. Okay, now let's move on to the next node. Depth is 1, value is 5. Can 5 be the child of 4? No, 5 depth is 1, 4 depth is 2. Okay, now let's look in the previous node. Can 5 be the child of 2? The depth of 2 is 1, the depth of 5 is also 1. No. Okay, let's look at its parent. Can 5 be the child of 1? Yes, the depth of 1 is 0 and the depth of 5 is 1. Okay, but 1 has already a left child, so 5 is going to be its right child. Okay, now let's look onto the next node. Can 6 be the child of 5? Its depth is 1. Yes, because the depth of 6 is 2. So as it don't have any left child till now, so 6 will be its left child. Okay. Can 7 be the child of 6? No, because the depth of 6 is 2 and the depth of 7 is also 2. So let's look at its parent. Can 7 be the child of 5? Yes, but right child, because it already have its left child. Okay, so we have seen that somehow, in some way, we get to know this information from the traversal, and we need to create this tree. And how we are creating this tree? By looking at each value and asking the question that whether this node or this value can be the child of this node. If yes, then attach it. Otherwise, look at its parent. Right? So what we are doing is, we are just simply pushing the elements, and asking, can this be its child? Can this be its child? No, then we are removing this element and looking at its parent So what data structure we can think of? Stack. You can also solve this question using recursion, but like the code is going to be almost of same length. Like first we need to check whether it can be its child or not, and if not, then we need to do a lookup for its parent, and also those coding steps are going to be almost same, so we will be doing them manually. So that's why you can think of a stack data structure, because we are asking the question at every point, can this be the child of this node? If no, then look at its parent. If no, then look at its parent. Okay, so let's see with some another example that how we can solve it with stack. Okay, so let's take this example. So first of all, what we need to do, we need to take out that information of depth and values from this traversal. Okay, so let's see. So depth is 0 and value is 1. Again depth is 1, value is 2. Again depth is 2, value is 3. Again depth is 3, value is 4. Again depth is 1, value is 5. Depth is 2, value is 6. Depth is 3, value is 7. Cool. Now let's see how we can create the tree with the help of a stack data structure. Okay, so let's create a stack first. Okay, so in the starting, our stack is empty. It means we have not encountered any node till now. It means the first node is going to be our root node, and we will simply push this node in our stack. Okay, now let's go to the next value, which is 2. Okay, so how we will check whether this can be the child of this node? It means we also have to keep the track of depth of each node in the stack. Okay, but no, we don't need to, because we will keep the track of the depth with the help of the size of the stack. Okay, so till now the size of the stack is 1. It means depth is 0. Yeah, depth is also 0. Okay, so if the depth of this current node is equals to the size of the stack, it means yeah, this can be its child, because the size of stack is 1. It means depth is 0. It means 2 can be the child of 1. And if 1 has not any child till now, so we will make it as its left child, and we will simply push 2 in our stack. Okay, now let's come on to the next node with value 3 and depth 2. So the size of our stack is 2. It means depth is 1. Yes. Okay, so yeah, 3 can be the child of 2. Okay, we will simply attach 3 with its left child. So you see here, I am creating first these information and then creating the tree. with the help of stack. But in the code, we will see that one by one we will be doing all these steps in a single pass only. We will not be doing one pass for creating this information and another pass for creating the tree. No, we will do this in a single pass in the code. Okay, now let's come on, let's push the 3 in our stack, and let's come on to the next node, which is 4 with depth 3. Okay, so check for the size of the stack. Yeah, it's 3. It means now depth is 2, so 4 can be the child of 3. Okay, now simply push 4 in our stack. Okay, now let's come on to the next node, which is 5 with depth 1. Okay, now let's check for the size of this stack, which is 4. Okay, and the depth is 1. So pop out the elements from the stack till the depth becomes the size of the stack. Because if the size of the stack is 1, it means depth is 0, and then it can be the child of that node. So we will pop out those elements, and now the stack size is 1 with the node 1. It means depth is 0. We can make 5 as the child of 1. What? 1 has already a depth child, so 5 is going to be its right child, and we will simply push 5 in our stack. Okay, now let's come on to the next one with depth 2 and value 6. Right now the size of stack is 2 only, because what we are having is 1 and 5, right? So size of stack is 2. So yes, 6 can be the child of 5, and it is going to be its left child, as till now it don't have any child. And we will simply push 6 in our stack. And now let's encounter the another value, which is 7. Yes, with depth 3, and the size of this stack is also 3. So yeah, 7 can also be the child of 6, and it will be its left child, as it don't have any child till now. So yeah, we have created our tree with the help of stack data structure. So let's match it with the given answer: 1 2 3 4 1 5 6 7. Yeah, 1 2 3 4 1 5 6 7. Cool. Okay, so let's see its code once. So see, first of all, we have created a stack data structure which will store the nodes, and initialized n with traversal.size, and root with a null pointer, and I with 0. Now we will start iterating in our traversal string, and we will initialize two variables depth and value, and we will count all the dashes in a one go, like 1 2 3 4. So how many dashes are occurring in a contiguous manner? So we will count all those dashes, which will give me the depth of a particular node. So in this way, I will count all the contiguous dashes, and this node value can be of 2 digit, 3 digit, 4 digit, doesn't matter. So we will need to find its complete value and not a single value. So that's why we will need to check if it is a digit, then we will simply do it with value into 10 plus that value. Let's say if we have let's say if we have 2 3 10, something like this. Now how we will calculate this 23 value? So first of all, we will encounter 2. Okay, initially our value was 0. Now our value will become 2. Now we will encounter 3. So what we will do? 2 into 10 plus 3, which is 20 plus 3, and it will become 23. So in this way we will get our node value. Okay, now we will create a new node with that value, and if the stack size is greater than our current depth, then we will pop out the elements till our stack size becomes equals to our depth. And if stack is empty, it means we have not encountered any node in the tree, or we have not initialized our tree. So that node is going to be our root node. Otherwise, we have already started building our tree, and if a particular node doesn't have its left child, then that node is going to be its left child. Otherwise, that node is going to be its right child. And after this, we will simply push that node in our stack and return the root node. Okay, so let's talk about its time and space complexity as well. So as we are just doing a single pass, so its time complexity will be big O of n, and as we have used the stack, So its space complexity is also going to be big O of n. So yeah, this was all for this question. I hope you get it, but if you still have any doubts, then you can post in the comment section. I will surely try to answer them. Till then, bye guys, see you in the next video.